Okay, the last gas law we're going to talk about is called the ideal gas law. This is also abbreviated as PIV-NERT. I know it's kind of a weird thing, but that's what they will tell you in college is PIV-NERT, PV equals nRT. So with the ideal gas law, it is very, very specific units. Before now, with Boyles and Charles, we've been able to do any unit of volume, so either milliliter or liters or pressure. Didn't have to be in an exact unit. The only thing that had to be in the exact unit was Kelvin for temperature. But in the ideal gas law, we have to have very, very specific units. So for P, that's pressure. That has to be in atmospheres. V for volume has to be in liters. Our N represents number of moles. So whenever you see N, that just means the number of moles. T, of course, is temperature, which has to be in Kelvin. And then R is a gas constant. So because it is a constant, it always has the same value. So R is always going to equal this 0.0821. And then the units for this are liters times atmospheres divided by moles and Kelvin. So how they get the gas constant is by taking all of the other values and doing an equation out of them. So remember our value for volume right here. This is how they're calculating the R. So remember 1 mole of gas is equal to 22.4 liters. That's where they're getting that. At STP, which is standard temperature and pressure, our pressure is 1 atmosphere. We're dealing with all of this at 1 mole. And of course, at 0 Celsius, that's equal to 273 Kelvin, which again is our standard temperature. So we plug all these numbers in, the 22.4, divide that by the 273, and we get this 0.0821, which is every time you see an R, you're going to plug in that number. And then the corresponding units help cancel out all of these other units up here. Okay, let's go ahead and do a couple examples. Right here, number 1, determine the pressure exerted by 7.23 moles of oxygen in a 4.5 liter container at 55 degrees Celsius. Oh, and of course determine the pressure. So these questions are going to look a lot different. You're going to have a variety of variables. And you're only going to have 4 variables instead of 5 because the R value is constant. So let's go ahead and assign variables to these. Pressure, of course, is going to be our P. That's our unknown. And we have 7.23 moles. So that's our mole, which is going to be our N. Then we have 4.5 liters. This is a volume. 55 Celsius, that's a temperature. And now you have to make sure you have these in the correct units. So pressure is going to be in atmospheres. Moles is correct. Liters is correct for volume. But what does temperature need to be in? Remember, it needs to be in Kelvin. So we're going to take 273 and add it to the 55. So we're going to get 328 Kelvin for our temperature. So that's the temperature we're going to use, is right there. Okay, now we're just going to go ahead and we're going to plug it into our equation. Our equation is PV equals nRT. So right here, our P is our unknown. Our volume is this 4.5 liters. That's going to equal our number of moles, which is 7.23 moles. Now remember, R is our gas constant, so this is 0.0821, and then the units for this is liters times atmosphere all over moles times Kelvin. And then our temperature is 328 Kelvin. Okay, so now we've just plugged in all of these variables down here below. Now it just becomes a matter of math again. We're trying to solve for pressure, so we're going to divide by the volume, which is 4.5 liters, on both sides of our equation. And this is now going to cancel out our 4.5 liters on the left side. And over here, the really cool thing is that it's going to cancel out all of the units except for your units of pressure. So because you have all these units in the gas constant, you're going to notice how everything cancels out. So notice how moles and moles, because that's below, that's going to cancel. Our Kelvin is going to cancel. Our liters is going to cancel. And oh, look at that. Atmospheres is left, which is a unit of pressure. So again, always put your units in these equations, because if you make a mistake, you're going to catch it because it's not going to cancel out. And it's so easy to forget to convert something if needed. Okay, now we just have to do our math. So we're going to take 7.23, we're going to multiply that by the 0.0821 and the 328, divide that all by 4.5. And for this answer, we are going to end up with our pressure equaling 43.27 atmospheres. So once again, to double check this, whenever you have time on a test, double check. Go ahead and plug in that 43.27 back into here, 43.27. And if you multiply that by the original equation, by the 4.5, that's going to equal the 7.23 times 0.0821 times 328, give or take some numbers for rounding issues. Okay, let's do another example. This is, by the way, my favorite gas law, just because it uses a variety. You've got the pressure, the volume, moles, temperature. So I think it's a fun gas law. Okay, let's do number 2. Determine the volume. It's our question mark. Occupied by 322 grams of nitrogen gas at 67 degrees Celsius and 0.42 atmospheres. So let's go ahead and look at what we have, because again, remember, these gas laws are going to be all scrambled up when it comes to a test. So you need to make sure you know which ones you have to use. Okay, so we obviously know that our volume is V. And right here, grams is going to be able to be converted into moles. We've got a temperature and we've got pressure. So if we look at this, we've got a volume, we've got amount in moles that we're going to convert to moles, we've got temperature and pressure. Well, this has to be PivNert. But now you have to make sure that all of your units are exactly what PivNert wants. So volume right here should end up being in liters. Our amount of substance has to be in moles, so we have to convert 322 grams of nitrogen. Remember, this is a Brinkelhoff. This is a mistake that is very commonly made. Don't forget that it's N2 because it's Brinkelhoff. It's a diatomic. And so 2 atoms of nitrogen is going to be 28.01 grams. And that's going to equal 1 mole of nitrogen, which is going to equal 11.49 moles. So there's our value up here, 11.49 moles. Okay, then we have temperature. So our temperature again has to be in Kelvin. So 273 plus 67. Sorry, I've got a little frog in my throat. It's going to equal 340 Kelvin. So we can go ahead and make that 340 Kelvin. And then pressure's in atmosphere, which is what it needs to be in. So now that all of our units are in the correct variables, we can go ahead and plug it in. So remember, we're plugging it into this equation, PV equals nRT. Okay, our pressure is 0.42 atoms. Our volume is what we're solving for, so I'm just going to put a V. Our number of moles is 11.49. Our R is our gas constant, so it's always going to be 0.0821 liters times atmospheres all over moles in Kelvin. And then our temperature is going to be 340 Kelvin. Okay, so again, now it just comes down to math. Let's go ahead and divide by the 0.42 atmospheres because we want the volume by itself. We're going to do that on both sides. Okay, now our 0.42 atmospheres cancels on the left, And the magic of canceling our units on the right is going to happen, and that's all because of this ideal gas law. So right here, our moles cancel, Kelvin cancel, atmospheres cancel, and look at that, we're left with liters, which is what we want because that is a unit of volume. So let's go ahead and do 11.49 times 0.0821 times 340 divided by 0.42, and this is going to give us an answer of 763.65 liters. And once again, if we take this, we plug in that answer for V, and we times that by our pressure, and then we equal that to this side on the right, this side, that should equal the same thing. So that's going to correlate with the answer perfectly. Okay, if you have any questions, let me know. I hope you appreciated PIVNERT, also known as the ideal gas law.